today we have this power supply. I bought this faulty for local marketplace, and it is the EUR version, and it says doesn't power on. So let's test that. It's currently unplugged. 3, 2, 1. Let's take our multimeter, go to DC mode, and actually this Nintendo 64 actually does have a pinout. See if you can see that. There we go. The top right is 3.3 and the lower one is 12 volts. Those three on the left there are ground. So if we just take our black probe on the left side and the 3.3 line, we should have something, and we do not. And if we go to the 12 volts, we have nothing. So it is faulty. Let's try to open it up and see what could be wrong with this. My mate Vince, he has done a couple of videos on these already, and what happens is a couple of resistors go open line. So let's see if that will be the issue with this one. And oof, it's tight. I need to get back into the gym. But anyway, if you have no experience working on power supplies, please don't do it. It's dangerous, or at least hazardous. There's over 300 volts in these bulk capacitors. They could hold a charge for a long period of time, so please just see this as entertainment. And I have some experience working on these before, and I have confidence in that I can fix it. So here we go. It's still stuck down, but it is opening up in the corner here, and there we are. Okay, so I have it unplugged now. Let's take it out of the shell. And a reminder, we could still have over 300 volts in this big capacitor. We are out of there. Put this down. So the first thing I would like to do is to discharge the capacitor. And what I like to do is just get in there with my multimeter, go to low impedance mode. And what happens is the multimeter actually put a 2.2K resistor and a PTC in series. So we will have a load, and that will discharge the capacitor, which I believe to be here. These two, let me zoom you guys in. We have 200 volts. It is draining. Put that there. And just go back to the voltage. And there you go, it's drained completely. That is just the capacitance charging up from the multimeter. So we're safe to work on this now. And we do have a little bit more information by the power supply now. We know that the capacitor, it is getting the voltage. So we can assume that the fuse is good, the bridge rectifier is good, and the filtering on the primary side is also good. But let's check it out just to make sure. We have the bridge rectifier here. We have the bridge rectifier here. And we have the AC coming in here. Have some filtering. On here we have a little small thermistor, I believe. And here is our output, of course. And here we have the switching device. Probably a MOSFET, transistor, whatever. And on this side right here is what I assume to be a rectifier diode for the output. But yeah, basically what happens is, let me zoom you guys in. Let's see, these resistors go bad. And there we go. So we're looking at these two resistors that usually blow open. So let me remove this gunk a little bit. So we can take a measurement. I can't really remember what the value of these should be, but it definitely shouldn't be super high resistance. First resistor is around 200 ohms. 200 ohms or so. I believe that is fine. But the bottom resistor is open line. So you guys can see that. Let me try to get you in the shot. Yeah, it's a little bit awkward. You guys can't see, but I am on the bottom resistor now, prodding. And that is, oh, my camera or my face is a little bit off. That is, let's see, that is fine. We are at 220 ohms. If I can get my probes on it. Yeah, 220. And that should be fine from memory. And let's go to the top. I see, let's see here. I see 152. That is what? 1.5K? Prodding now. And we have 36. Oh, went to the bottom resistor. We have 36 megs. That's what I saw. Yeah, 36 megs. So this resistor is blown open. So we need to swap that out. So what can we do? We need to get this board out. Or we could try to swap the resistor just as is, but I would like to take the board out. It's not really that difficult. Just a through-hole component here on this board. So let's desolder this. Here we are under the scope. The pins are prepped with flux. Now we can just come in with our soldering iron. I'm gonna be using my 245 handle and 350 Celsius. If you're curious about any of the tools that I'm using, I have some links in the description, so you can check that out. I got flux, I've got my soldering wick, and the station. So here we go. Let's try to wick that away. And unfortunately, these pins are bent, so we have to bend them back in order to take the board out. But you can see the pads, or the solder, excuse me, is coming out. So I'm just gonna go through these. Okay, so the board is coming out, I believe. Left is loose. And there we go. Let's check under the scope. And we can see that the vias are still intact. Except for maybe this one. We did a little baby damage there. That is completely fine though. The trace is still solid. And the VI is still functional. Just a tiny damage there. Here's the board we need to work on. And our resistors. Let me get you guys in focus. Okay, and there's our resistor. So we were looking at this one, which should be 220 ohms. And this other one should be 1.5K. Now, I have scraped a little bit of soldering mask here. Oops, sorry. But we should still be okay. We can add some curing mask or soldering mask after we're done with the job. So I'm not gonna reverse engineer the entire board. That is a little bit beyond me, but obviously this transistor or whatever it is, voltage regulator thing, maybe you guys can let me know in the comments what it is, but probably gives power to this IC, which is, or should be, maybe, the feedback circuits controlling the, or reading optocouplers here. But yeah, let's use our resistor book and find an appropriate resistor to replace this with. And I forgot to put on my mic while I was soldering, but that is fine. Let's just take some solder mask and try to recover the appearance. And this is a real life soldering mask, so it should cure quite fast. 3 seconds it says on the advertisement. I haven't really tried it myself, but yeah, we can just add a little bit. But yeah, we can just add some where most of the damage was. No problem. This is cosmetic anyway and won't affect the function of the circuit. So there you go. It's gonna come in with my UV light and we're good to go. So that was just another 10 seconds or so. And yeah, we're good. I'm fine with this. So let's get the board back. Okay, finally I got the board back in. So let's solder it in place. Some flux down. Let's come in with the C210. Clean our tip. Just some nice hand soldering. There we go. I'm gonna do some cleanup. Okay, and there we go. Let's go for a reassemble. We can give it a test. Okay, so here we go. We have the power supply reassembled. Let's go to test. It's unplugged at the moment. 3, 2, 1. It's live. The moment of truth. Do we have voltage? Or so if we did our job right, we should have 3.3 on top and 12 volts. So let's see here. Grounding on the left, right, remember. And 3.3 here. And we do have 3.5. That is good. Do have 11 volts, which I consider to be good. So that is fixed. Let's try it on an N64. So we have our N64, our fixed power supply. Let's plug that in. Heard a click, so it is in place. See, we get a light, and we do get a light. Great news. See if it plays a game. Hopefully, and it does. So I'm gonna run this power supply for a couple of hours, see if we get any excessive heat or something, but this is a fix to me. So just a burnt resistor, that's all it took, and a little bit of sweat and work. So thank you guys for watching, and I'll see you on the next video.